Welcome back. Section 8.2. Area of a surface of revolution. In this section, we are going to find surface area of a surface which is obtained by rotating a curve around an axis. Before we go to the entire area of a surface of revolution, let's recall a few topics. Suppose we want to find area of a sector of a circle. Sector is this region subtended by a certain angle. So, my circle has radius L and I'm looking at a sector subtended by angle theta. Okay, how do I find this area? Well, this is seen with a simple proportion problem. Suppose I make a table with angle versus area. When the angle is 2 pi, I'm looking at an entire circle. Well, we know the area of an entire circle, pi radius squared. So when the angle is theta, we are looking at a proportion. What is the area? Area is theta times pi L squared over 2 pi. Okay, so cancel the pi's, L squared theta over 2. That's the area of this sector. With this information, let's find area of the surface of a cone. Here is a cone with base radius r and the oblique length L. Suppose I cut my cone, then it opens, unravels with the side length of L, and this arc length is 2 pi r. Why is it 2 pi r? Because it is circumference of the circle. So that is 2 pi r. Now, the question is, well, we can find the area of this, which will be the surface area of our cone, if we knew the angle. Well, how do we find angle? This is again a proportion problem. If the angle were the entire 2 pi, then the arc length would be 2 pi radius being L. Now we don't know the angle, that's your question mark, but we know the arc length, that is 2 pi r. This r, mind you, is different from the radius of our circle here. This r is the base radius of your cone. All right. So you have set up a proportion. Angle is 2 pi times 2 pi r over 2 pi L. Simplifying, you get this angle in radians is 2 pi r over L. All right. You know the angle, you know the radius of your sector. So what is the surface area of the cone, which is area of the sector? It is, you have the angle, radius squared over 2 times angle. Simplifying, you get pi r L, square units. So that is surface area of the cone as it is area of the sector. All right. Continuing. Now what about a part of a cone? So that's the entire cone, but I'm taking only part of a cone. So here is base radius R2 and there is the other radius R1 where we cut off our big cone. The side length here is L. Well, for the big cone, the side length is L plus L1, the entire length. All right, this given surface is obtained when a smaller cone is cut out of a larger cone. Okay, you take the large cone, cut out the smaller cone, whatever is left over is the surface we are looking at. Okay, so required surface area will be surface area of the larger cone minus surface area of the smaller cone. Well, we just saw surface area of a cone is pi base radius times length. Well, larger cone has base radius r2 and length L1 plus L. The smaller cone has base radius r1 and side length L1. Okay, so area of the larger cone minus area of the smaller cone. But we don't want L1, we want to replace L1 by an expression involving R1, R2 and L. So we now use similar triangles. Where did these similar triangles come from? Look at this. If I join a line with the vertex, the center and the center here, I look at the shadow on a certain plane. In other words, I'm looking at a cross section. I get huge triangle and a small triangle. All right, so that's the picture here. L1L, ABD, small radius, bigger radius. Well, we have similar triangles, a large triangle and a small triangle within it. Why are they similar? They are both right angles and this angle is common to both triangles. So that's all you need. Two corresponding angles to be of equal measure and you have similar triangles. So what does this say? The large triangle L1 plus L over R2. Okay, so corresponding sides. And here are L1 over R1. So in similar triangles, what do we have? Corresponding sides are proportional. Cross multiply R1 times L1 plus L equals R2 times L1. Simplify or distribute R1 L1 plus R1 L equals R2 L1. All right, move the L1 over. R2 minus R1 L1 is R1 L. Okay, so we moved this there. So L1 is eventually R1 L over R2 minus R1. Why did we need this? In this particular formula, L1 is not needed. We want information in terms of L, R1 and R2. So I'm going to replace L1 here by this expression. So you have L1 is replaced by R1L over R2 minus R1. All right. Upon simplifying, you will find pi L R1 plus R2. Well, let R represent average of these two. That is R1 plus R2 over 2. Then R1 plus R2 is twice R. Okay. In other words, R1 plus R2 is twice R. Surface area of our particular surface is 2R pi L. In other words, 2 pi RL square units. Okay. 2 pi RL square units is the surface area of such a surface. All right. So we'll continue. By the way, this entire lecture closely follows text by James Stewart. All right. Now we are almost ready. In our next video, we will worry about finding surface area of the surface obtained by taking a curve such as this and rotating it about the x-axis. Until then, bye.